Good morning. After we have set up the functionality to have proper location tracking in the REPL yesterday, now we can start seriously to work on the expression parsing. For example, if we have, 7 times 4 plus 9 times 3, this is not the way that we want to parenthesize it at all. If anything, we would want to parenthesize it the other way, such that it goes like this. 7 times 4 plus 9 times 3, like that. Like that. That is what we would want the parser to generate by default, not the other thing. So I think let's do the first thing first, and that should be a relatively simple change in how we parse binary expressions. That we should still be able to do locally. Let me get rid of this, which I had for performance testing, but it turns out that keyword matching really is not but keyword matching really is not the big time taker here at all. Yeah, like I said, the black stuff for now is not interesting. What we're interested in is the parser, and we'd like to change the way that we're doing things. I think. And by default, we at least want to parse in the other direction. And the reordering according to the stack and such. I do think that since order of expression evaluation is not really something that the parser does, I'm thinking about doing the reordering as a separate step. Like not doing it in the parser at all, but when we do the recursive descent to parse binary expressions, what we at least want to do is to parse left leaning. Right now we pass right leaning, we advance on the right, but what we want is to parse left leaning. So let's try to do that. I think I have a file in which I sketched that out, a parse expression over here, where the left leaning thing goes like this, where the result equals parse binary expression passed in the LHS. Then we get the next token type, and we assert that that is a primary token, right? Because if you look at the expression over here, the last thing here has to be a primary token. It can't be anything else. And let's just integrate that into our regular parser. Let's take this expression, this specialized expression parser. Let's remove maybe the auto-generated code and the identifier table and the other code we currently are not looking at. Where do I want to go? Alright, so I think I want to have this convenient function that detects the primary token. Yeah. First, yes, that is what we want to do by default. When we hit a primary expression, by default we now want to do this, and then we call MetaC parse expression with the results, and then in the other case, we still want to parse a binary expression, but we go left leaning. So we say this equals left, and then we parse a binary an expression with the result. The EE parser is something that I wanted to do in the beginning. It's not going to be a thing now. So, oh yeah, LHS is simply left. And parse binary expression is we just call the regular parse expression thing. So if now we do 12 plus 12 in expression now, this now fails, which is interesting. Okay, it just infinitely loops. This would imply that we don't advance. Now we match the parse piece. We match the token type. So what is the peak token type? Peak token type is plus. I think we have to step through this. So let's do primary expression. Primary expression still work. So, and the primary expression goes bonkers, right? So let's see what happens. We are in past binary expression. To our left, there is a signed integer, the 12. Should be able to see signed integer value 12, and we can also look at the location. It would be on line 0 column line 1 column 0 actually. Let me set up a watch which would be self location storage locations of 0. The parser is not called self. Oh, yeah, the location storage is not in the parser, it is in the lexer, it exists per token. There we go. And yeah, it starts at line 1, starts at column 1, and ends at column 1. That's weird, but it seems to be what it is. So now this expression is here. If we go down from where we broke, we should be able to look at the precedences. The left has a precedence 2, the right has a precedence 4, because addition has a higher precedence than the literals. And now we go into MetaC parse expression. And I guess this is where things go sour. Because again, the left here is assigned integer, the right is the addition symbol. Which we haven't matched yet. So this is not actually something we can do. We have to call parse binary expression. We can't just call the thing to parse a regular expression. We are in a binary operator. So we have to do this. Parse a parse binary expression. Okay. Well, now we have done an assign. Which doesn't have a precedence. So result E1 doesn't work. Oh, we haven't allocated a new expression yet. Our result is a 0. It is null pointer. So let us do that. With a new expression of the type that's to the right.